So, does anybody have a definition of what testing is? Yeah, Jack. Attempting to figure out whether or not your code works. I like that. Any other definitions? Oh, sorry, pardon? Sure, requirements that have to be met. Sure. Alice.
Yeah, basically just writing expected like inputs and outputs.
Sure, expecting certain outputs given certain inputs from code, right? I like this too because given certain inputs is something I want to talk about specifically too when we talk about what a test is. Yeah, I like the idea that a test is just, it's something that you expect to have happen and then you go and see if it's actually happening, right? The idea of testing is that we're comparing something that we're seeing against some expectation of what we might see, right? Which is actually why a parent might tell a child, like, why are you testing me? If a child asks for dessert like the 5th time, right? It's like, why are you testing? You're expecting to get a dessert at some point, but I've already set an expectation with you that my answer will continue to be no. And maybe I'm saying, why are you testing me? Haven't I already revealed to you through my interface of parent to child communication that the next answer will be no? Why do you keep on checking for more answers? But the kid's like, I have this expectation. I really want to get to this ice cream. So it keeps on asking, right? A kid that didn't want ice cream is not going to ask me for ice cream. Right? If I don't know how my code is supposed to work, I can't test my code. I haven't indeed tested my code until I've come up with some sort of expectation for how the code is going to behave, right? So I believe that coding is a process where we are constantly refining our tests and constantly checking back on those tests to make sure that our code is working as intended, right? We're going to talk about RSpec today, which is a way that we can assemble tests, pre-write them, right, add to them cumulatively over time, and then run them all in one big batch. That's super helpful for when we have like a mature code base and we want to make a change to it, and we want to ensure that that change is safe. And maybe we already have like 300 tests that are making sure that the code does this thing when this thing happens and talks to this thing at the right time, and then it's like, hey, we need to change our whole Rails version for this. Well, a lot of those things might be broken. I don't know which ones. It's nice that we have this 300 like test automated suite. And hey, wouldn't it be nicer if we could set up a whole suite of automated tests to run every single time our GitHub repo got a new master branch? Like spin up a tool to take that repo, clone it down, make a copy of the app, run the whole app against all the tests, make sure the tests all turn green. In fact, and this is not hypothetical, this is how people actually do their work. This is what we'd call automated continuous integration. There are apps that are set up that have RSpec tests, testing that the models, that the classes do what they're supposed to do, and also the test that like when you click on login and type in a good username and password that it'll log you in, and also if you click on this link and fill in this form, it'll create a new tweet to your like social site or whatever. They have all those tests. They run automatically every time the code changes. If the tests automatically, if they pass as they run automatically, then the code will automatically get updated and redeploy a new version, but only when all the tests pass. That's called like continuous integration or continuous deployment, right? That's a very nice, mature testing philosophy to have baked in. But at the other end of the spectrum, we have what I call like eyeballs and crossed fingers, which is me going like, hey, it said undefined method plus for nil class, and I remember something about when I use a setter that I'm supposed to say self dot and not just call the method name, because Ruby gets confused. So I'm expecting that if I change this to say self dot age plus equals 1, to if I say that instead of just age plus equals 1, I'm expecting that'll make the error message go away. That's a test too, right? I have some code that wasn't working right, and I made a change to the code, and I'm saying to myself, I expect the test will not be there anymore when I run this. And then you run it, hoping to see that the test is gone or that the number of running tests has changed if you're doing fail fast, and then you adjust, right? That's a test too, because you set some sort of expectation. I'm here to tell you that like setting an expectation, it makes the error message and the test go away, is probably the more Bush League kind of expectation that we could set for ourselves, right? Because that's not really specifically about the code. That's about something that happened when we ran the code that we don't like. And if I'm only coding to make error messages from RSpec tests go away, it's possible I'm not introspecting deeply enough into how the code is running under the hood to make myself somebody more capable of avoiding those errors in the future, right? So today we're going to talk about test-driven development. If a test in basic terms is me saying how things should behave, and then checking to see if they behave that way, then test-driven development is a process where we write our tests before we write our code. That's all it means, right? That means that if I have a piece of code that knows how to send an email, if it was written via TDD, I wrote the tests that would clarify that it can send an email, and then I wrote the code that passed those tests. So I only have code because I wrote code that passed tests, right? TDD is more time consuming sometimes in terms of how many, like if I had to write 3 features in a week and I knew I had to test all of them, I'd be more nervous than if I had to write 3 features in a week and I didn't have to test any of them, because writing tests means writing code, and writing code takes time, right? But if I had some code that I had to maintain that was written 3 years ago, and that code was written based on TDD, and then I had some other code that was just kind of written and then people slapped some tests in after the fact or didn't put tests in at all, I'd be much, much less comfortable working with the untested code, because untested code is very difficult to maintain. You don't really have anybody like checking lists and saying this is how things work. So philosophically speaking, like what we're trying to do is always put ourselves in a position to win as coders by never putting ourselves in a position where the amount of uncertainty or the pain of change makes it too difficult to change our code. Why? Because apps will never live forever, because in a changing world where versions change and systems change and machines change, right? Imagine talking to somebody like coding for like MS-DOS 20 years ago and trying to get them to think about like what the difference between iOS 4 and iOS 7 would be, right? Which that has made us all delete apps in our lifetime, right? Except that person couldn't even foresee it. So if that app needs to live in perpetuity, that app needs to be able to grow and maintain over time, right? Which means we need to be able to change our code over time, which means we need to be able to not break the code as we change it. This is one of these things that we have as a tool to keep us in that zone, right? If I have tests, that means that I can always make sure that they're going good. Once I've got them passing the first time, then I can make changes, I can add stuff on, I can add new tests. And because code will not live forever, if I want my code to live as long as possible, then I need to get good at writing tests and I need to get good at reading tests. So that's the other kind of focus that we're talking about. Because otherwise I'm really just writing code to put code on the screen, right? I can't tell you if it's gonna work well. I couldn't, if I don't have my tests formalized in some way, right? Maybe I myself, my own eyeballs, have checked every single thing. I've got driver code and I've run it myself and I've watched every output that I puts to the screen be exactly what I expected. This morning I had that whole list of trues that I devised to print to the screen to tell me if they'd all work. Had like the explanation and then the word true. That's kind of like a baby version of RSpec, right? In between eyeballs and having like a full-fledged RSpec test, we can say this equals this and hope to see a puts out of true. If I don't have anything at all like that, then it's hard for me to know if I know what I'm trying to do with my code, right? But if I can declare a case that should return true or false based on a certain condition, then I'm getting close to a knowledge of my code. So the most immediate thing that testing helps us do is make sure that we have our heads on straight about the work that we're trying to accomplish in our code. So today I want to review the basics of a one-to-many relationship, and I'd also like to do that in this lens of testing. I've got an RSpec file called shirt spec, and I wanted to point some things out. I've got in this intro testing, I've got a folder called spec, right? I've put in shirt and brand spec files. Conventionally, they end in spec.rb. Generally, in a spec folder with RSpec, we're going to have some sort of spec helper file, and that file's job is going to be to kind of organize all the work that RSpec needs to do. So file requirements might live inside of a spec helper. I've neglected to provide one because I want to be as explicit as possible that this is just regular Ruby, right? What I intend to do is create some shirts and some brands, make sure that they behave themselves here, right? I could have done this in driver code, could have done this in a runner file, could have gotten into binding.pry called shirt.all to make sure that that class method works on shirt. I'm deciding to use TDD to kind of formalize it in RSpec and then code to match that test. Still Ruby, still needs to run wherever it runs, so requiring is still part of this. This is where it gets weird. RSpec is what we call a DSL, or a domain-specific language, right? It's a language that we have that's specific to the domain of testing Ruby code. So we're gonna have keywords and things that don't really make sense elsewhere in Ruby. We're gonna see some words that we've maybe used in other contexts, like do and end, but the blocks that they imply are now gonna be for an RSpec context. The top block that we'll be in a test like this is called describe. and basically describe takes a string that talks about literally the thing we're describing. All these tests in this shirt spec file are about testing the shirt class, so I'm saying we're describing shirt up here. Within a describe, we can nest a context if we want to. We don't have to have a context level in our scoping, but we can. The context could tell us, hey, these are our class methods for shirt, right? Maybe I have user methods, and when the user is logged in, I have one context. When the user is not logged in, I have another context. Maybe I have a farm class, and I have a context for the farm in the winter versus how the farm responds to method calls in the spring or the summertime, right? So context lets me take different tests that are about the same thing being described and break them up by that subcontext. Essentially, this stuff is here to help RSpec build strings, right? When I have a failing test within shirt class methods, it's going to tell me that the name of the test is shirt space class methods space, and then this first test can return a list of all shirts that have been initialized. So within the context, we finally get into the meat of things. This it block is where an RSpec test lives. Between the do and the end of an it, we either have an expect statement, that's an RSpec specific syntax, this expect, which is called a matcher. And what a matcher does is it handles the second 2/3 of a test. Well, wait, we didn't even talk about 3 parts of a test yet, so let me back up. An individual test has kind of 3 ingredients. There's a given, a when, and a then. The given is whatever kind of data or state or setup steps need to happen, given that we've set our field up this way, given that we've prepared this experiment in this way, right? And then there's the when this certain method gets called, right? Or as we call this method and we look at kind of side effects that happen, and then we set an expectation. Then the method returns this, or then we go looking at one of those instance variables that the method was supposed to change, and we see that the instance variable is changed. So we have given, when, and then. So here's my given work inside of this first test, which, as we remember from describe, is about a shirt, and more specifically, a shirt's class methods. And the first test I'm trying to write is really for a shirt.all. And so I named this, it can return a list of all shirts that have been initialized, right? What I could do is even name the class method here, .all. That'll be kind of nice. When I run this test, I'm expecting it to say shirt class methods.all can return a list of all shirts, and that kind of gets my head on straight about what I'm trying to do. In here, I've attempted to create a new brand that the shirt's going to belong to, and then I'm attempting to create a new shirt that's gray under that brand. And then I'm calling shirt.all.length, and this is the RSpec syntax here. We have this expect, which takes an argument, and the argument is whatever code I want to run, whatever I'd like to see return a value or do something, right? So shirt.all.length with an expect like this with parentheses, now we have this .to, and if I wrote this out like standard Ruby style, you'd see that I'm explicitly passing this in as an argument, but that's a lot of nesting. Rubyists don't like that nesting visually, so you tend them to see the syntactic sugar at the end, where it just has a space in between them. So equal 1 is an argument getting passed into the 2 here. So overall, I'm saying that now that I've created a shirt up here with shirt.new, I'm expecting shirt.all to have 1 shirt inside of it, right? I'm also expecting shirt.all.all, Is everything in there of class shirt? This is a little too, I think, redundant, because if I'm only expecting there to be 1, couldn't I just do this? Let's get the first one. Shirt.all bracket 0, so the first shirt out of shirt.all should be a shirt, right? I don't want to put strings in shirt.all. I don't want to put brands in shirt.all. I want to make sure that each thing in that array is a shirt instance. So what I'm saying here is shirt.all.0 class equals shirt to be true, right? The difference between equal at the end here and b is a very like nitty gritty. You can always use equal safely. Sometimes you can also use b safely. Integers and booleans just kind of are what they are in Ruby. There's not more than 1 copy of the integer 21, right? There's not more than 1 copy of false. There's not more than 1 copy of nil, right? Those are just like singled, like they're just there where they are in Ruby's memory, right? When it goes looking for that number. But when you make a string hello, couldn't there be like 5 or 6 different string hellos if a string is just a collection of characters? So we'd use equal for things like strings. We might use equal for, let's see, other stuff that's like more mutable, right? I guess equal versus b is about like, are we just checking for the value of this thing, or are we checking for the essence of where Ruby is holding on to it? And there could be more than 1 copy of a string, so we might say equal for that, or we could say b. In either case, I've written this test. And I've written some more tests down here. Maybe I just want to focus on this first test for now. I've written a couple more. A cool thing that RSpec lets you do is you can pop an X before an it, and that moves the test to what's called a pending state. So you can run these tests, and RSpec's just going to kind of hop over anyone with an X, and that lets me just focus on the ones that don't have X's. So I can be in the process of writing tests and running them without having to like do a full unit of work of writing a test and the code to pass that test to see where I'm at. I can pause my test writing work and go and drill into one specific thing. Jason?
I think you left a bracket in there.
Probably. Where at?
In the second test you were showing that for sure.
Sure did. Nice catch. Cool.
Does it have to be an X? Could it be some random number?
I think it has to be an X. I could also say the whole word pending, I think. I think that'll work too. Or maybe if I just replace it with pending. I think that these both might work. It actually might give me trouble with one of these, depending on that version of RSpec that I'm running. They've changed words around a little bit in their syntax. Let me play with this. Let's get rid of you. Yikes. How do I? Yeah, there we go. That's right. And then we'll try this. So where I'm at, if I hit ls, I have a spec folder. So if I run rspec, when you run learn, it's an alias for rspec, so it does the same thing when you run learn. It looks for this spec folder, and then it will try to run all of the non-pending it blocks that live in any of the files that are contained inside of that spec folder. So if I say rspec, notice it says 1 failure, 2 pending, undefined method all for the shirt class, coming from line 40 in the shirt spec, right? And so this line right here doesn't work because the class doesn't actually have .all, right? So that's, I can run the test and I can see outputs now at this point. Jack.
What if is it possible to make like the variables extend to multiple tests? We put like brand and shirt the same test.
Yeah, I'm glad you noticed that. This is very repetitive, right? You see how in each of these tests I'd need a brand because the shirt requires a brand to be created because the shirt belongs to the brand, right? According to our domain model schema. And this is very similar to how like a tweet belongs to a user when we create it, right? Or how a song yesterday, right, belongs to an artist when you create it. So yeah, Jack's pointed out here that we haven't been very dry, right? And just because this is test code, we don't get to like break all of the stuff that we've been doing in our code. We still want to avoid repeating ourselves. RSpec gives us a really cool syntax for this. Inside of a given describe block, we can use the let keyword to set variables that will work for any test within the describe block. So for example, brand and shirt, brand and shirt, brand and shirt. Oh my goodness. Let's get rid of this. Put an extra Y on this. In case we hadn't gotten there by the time we got to this last test, I was going to bring it up right there. Using slickness and subterfuge. All right. So we established the given that we're testing. I'm actually going to leave it on this one because it's like part of these, but let me bring these back in. These both did work for pendings. When I bring these back in, I'm going to set brand and shirt differently. I'm going to say up here in describe, we'll say let brand. And so let will always take in a symbol of the variable that we're creating as an argument. And then it will also take a block. And in the block, we write the code that we want to run to set the variable in the parentheses. So this here would be brand.new, LRG, and this would be a shirt.new. We'll make it a gray one from the brand. Let's get rid of these for now, just for a second, to see if it will still work without it. RSpec, yeah. So we still have 2 pending, still have 3 examples, still have 1 failure. It has a problem with the undefined method all for shirt class, which means it's still gotten here, right? It's still gotten to line 43, and it's had no trouble. I guess we haven't really tested how many shirts have been created, right? Because right here we didn't actually say anything about lowercase shirt or lowercase brand. So taking these pieces out, they haven't really told me if these things are creatable within this test. Does that make sense? Like I commented these lines out, but whether these are here or not, nowhere down here do we refer to shirt or to brand. So another thing we could try is let's try printing out brand and shirt. Another way to see if we have a brand instance at the variable and a shirt instance at the variable, let's print them out and see if we have a brand instance followed by a shirt instance. Run it back, run it forward. There they are. You got to go up to the top because that's where the like quick input or output of running the test lives. But we did print a brand and we did print a shirt, and it has those pieces. What's interesting is that the shirt.new, notice how the shirt, it doesn't have any instance variables like the brand does. Maybe that's just because the class is pretty empty. That's it. The class is pretty empty. We haven't actually filled out anything about a shirt. So eventually we will have to write some code to start passing these tests as well. Right now though, we can see that brand and shirt, even though we declared them all the way up here in the describe, we can print them out and it knows stuff about them. This is also a fun piece. Let me show this in a different way. So if I said this, let brand do, like, because an opening bracket is the same as do and a closing bracket is the same as end. You remember that piece, right? So we have let brand do, brand.new, LRG. We could do this too. Puts setting brand. We could do the same thing here, do and end. I just want to show you like what's going on under the hood with this and why they set it up with this weird let syntax. It's a concept called lazy loading. And what it basically means is that your test should not have to know how to calculate the value of brand or shirt unless it actually calls on the value of brand or shirt. It shouldn't have to spin up one of these for every single test that runs. It should just be able to deal with this as it gets called on. So here I'm about to say P brand and P shirt down in this test, right? And then I'll also say here like P printed brand and shirt. If we take a look at what runs, notice here we had printed brand and shirt happen at the very end after we printed the brand and shirt, but before either of those things happened, we got this setting brand value printout, right? So what if I did this? What if I said printing brand and shirt? Oops, goodness, not like that. Let's bring this up. I'll say printing brand and shirt, ... And then we'll say P brand, P shirt, right? And I'm also gonna do this on the shirt. What I think is going to happen as Ruby runs this is it's going to go, okay, describe shirt, blah, 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 who cares? Because it's just let stuff, it doesn't care about it yet. And then it's gonna get into this first test, and then it's gonna see the word brand, and it's gonna go, crap, I need to know what brand is. And then it's gonna go up here and actually run this block to figure out what brand is. And then it's gonna figure that out and print out brand. And then right after that, it's gonna go, crap, I need to know what shirt is. And it's gonna come up and run the code that makes shirt be real in the let block. And so I think we're gonna see these helpful put statements come up, showing explicitly that even between when we call on P brand and P shirt, we have to go back up to that let space and like call on that code in real time. Let's see. Go back up. Past the pendings. Yep, we start printing. We're setting the brand value. Oh, I put brand in both. But yeah, we set brand and then we set brand. Technically, we set brand and set shirt. So let's make it say that. Run it back. Yeah, setting brand value, and then it prints out the brand, and then it says setting shirt value, and then it prints out the shirt. So when we say let, we're not actually setting those variables at that time. We're setting what the variable name is, and then we're telling our spec, whatever somebody calls on this variable name, here's the thing to return if you want to actually give them a value at that variable name. Yeah, Alice.
If multiple tests use those variables that you define that way, if like the first one does it and they get set back, like the first one calls one and it goes up and like actually runs that code,
Yeah.
does that then that same exact, does that get rerun like every test?
I think it will. I want to keep this on so that we can go back and check. That's why I wrote these like this. Normally I would just put it on a single line with the curly braces, but just for education purposes, I'm going to leave them in here now and we can kind of examine when they ran as we get more tests off the ground. So first, just for review, let's actually try to implement shirt.all, right? We know that a shirt needs to have, based on looking at some of these other tests, and this is a nice thing about our spec too, if I wasn't sure what to call that first argument getting passed in, Like, is gray the name of the shirt? Is gray the size of the shirt? Is gray the, I don't know, is this like a site where people on medical shows like wear stuff and this belongs to Meredith Gray? I don't know. I literally don't. But if I go down here, I get more information, right? Has a readable and writable color. Oh, if shirt.new, so if I'm going to read this test, I'll probably read it like this now. It has a readable and writable color. I'd come down here and see expect shirt.color to equal blue, and then I start asking myself, because this block doesn't have a variable called shirt, when I'm reading an RSpec test, I go up and start looking at the let block to see if there's anything that was defined as a shirt. So I come up here, I know that there's a shirt color that's supposed to be blue, and then I see here, oh wait, shirt new, gray, so that's not even the right test. This should be gray at first. But that tells me that my first argument in shirt should be color, right? Because shirt.new has the first argument getting pushed in. Down here, we're talking about shirt.color equaling that first argument. Whoever wrote this test is clearly intending that first argument to correspond to a shirt's color. So if I'm going to finish initializing this shirt, I feel like there needs to be a color, and there needs to be a brand, and they need to be set based on the arguments that came in. And how is shirt.all going to be defined? Pardon? An array, right? So am I going to say, like, how do I define the array? What's the syntax that I need? Add at all? Class variable, right? Add at all equals an empty array. What's a method so I can actually retrieve the value at this array? Self.all, right? That's going to be what kind of method? Self.all. Makes it a class method because it starts with self dot, and we'll return the value of add at all. So now let's run our test. Oh no, 3 examples, 3 failures. What happened? Expect shirt.all.length to equal 1, right? Well, here's a problem, right? Because when I first had written this test, we had, let's see here. When we first wrote this test, we said like P brand, P shirt. Well, this is weird. I was wondering, I thought it may be because we didn't call shirt.new, but since we called P shirt, that should be forcing the creation of a shirt still. Right? So why is it not ending up in the array? Oh, I didn't shovel. Thank you. Shovel and shirt. All right. What are you going to be, shovel and shirt all day? Come on. All right. What shovels into all here? Self. Why self? It's an instance. Oh, because we're in an instance method. But that's weird. I called shirt.new. That was a class method call, right? Because I called it on shirt. But I ended up in an initialize method that was an instance method. That's actually true. All those things are true. It's just a fun thing to remember, right? Like to be focused that when we call .new, that is definitely a class method. In here, self is definitely an instance, right? That means that there must be some Ruby running under the hood that's doing the handoff between the class scope to the instance scope as that instance gets created. And I won't belabor the details of that. It's just good to kind of think about that as a weird gate to jump over, and maybe as an exception that proves the rule about class and instance method calls and how scope works. In any case, now that we're shoveling in, I am thinking this will work, at least for one of them, right? The first test did pass, and I can tell because I see a dot before 2 Fs. That's one way I can tell, like looking at my output and like parsing and looking for my dots versus Fs. Dots means success, F means fail. I can also use process of elimination here to see like which tests are failing and which ones aren't. Here's what makes me uncomfortable, y'all. Because of the let syntax in this particular test, if I stop playing around with like printing shirts, I'm not sure this test will still pass. Right? Because since the let block is lazily evaluated, if I don't call on shirt to cause shirt.new to happen, then shirt.all has a length of 0 because no shirts were created. Each of these tests is kind of getting run in an isolated environment, right? So that we can really control everything that's in play. So even though I put the instructions for building a shirt up here, if I don't ever say the word shirt down here, then I'm not gonna get it. And I really didn't want to have this kind of stuff going on, but I guess I could for this one test, right? Maybe if I redefine brand and shirt for this one test, it actually makes it clearer why shirt.all needs to have a length of 1, because it corresponds to the number of shirts that were explicitly created in this test. I think that's one reason that I might want to be explicit about how this shirt is getting created. But another thing I could do, right, is I could just create some other shirt, right? I could say like brand.new equals Adidas, shirt.new, yellow. I could call this Adidas. I could call this test shirt. Pass this in, just so I don't like muddy up my variable namespace. I do want to have like shirt and brand be my kind of canonical ones from the top. But the important thing is that I needed to call shirt.new at least once to make sure that shirt.all.length equaled 1 and that the class of the first item that was saved was a shirt. And I think that's the case still. Great. So TDD basically means that I have a test that's written and then I write the code to pass the test. And when I'm trying to write code that passes a test in the TDD style, the other thing that we need to talk about, let's see what this, I'm gonna write the word grok. Does anybody know what the word grok means? Fully understand, like to feel it in your bones, yeah. It's like how you can't really grok whistling in an acorn cap until you can whistle in an acorn cap, and then when you can do that, there's stuff about like lip shape, mouth shape, wind direction, finger positioning that are harder to explain in words. It's just like, yeah, when you get it, you'll get it kind of stuff. So that's what I mean when I say grokking. Red-green refactor, when I want you to grok it, when I want you to know it in your bones, it's really about being like desperately unsure of yourself. So red-green refactor means that when we get a test going, the test needs to start red, and then we write code that makes the test go green, and then we refactor the code as needed, right? We talked about this earlier a little bit on like day 1 or 2, and we talked about shameless green as the idea of like make it green as shamelessly as possible. I want to highlight that the first step of red-green refactor must always be red, right? Because if I write a test and then the test goes green and I hadn't changed any of my code, then how do I know that it's my code that's passing the test, right? Does that make sense? A test is supposed to work for us, right? A test is supposed to be kind of a calcification of our expectations about code. And implicitly, we're saying it's expectations about our code that we have control over. Implicit in all of these tests are, because I wrote some stuff in brand and shirt.rb, right, in the stuff that we're including, because this code is here, these tests can work. If I were to delete these require relative things and all my tests returned green, I'm testing that something works, but I'm not testing my code, right? So if the test starts off going green, I don't yet know if my code has been tested. I would need to break it manually to return my code to a red state just to feel the reassurance that it is in fact my code that makes the test go green again, right? Otherwise, I could just be in a hall of mirrors thinking that I'm looking at a crowd of friends, right? And I don't want that. Plus, in real life, there's a lot of tests that will just return green without touching your code at all because of things with the web and how things happen with like feature tests. But we'll get into that in more detail later on when the time comes. Right now, I've got this test. This shirt.all test seems to be working okay. I found the way to make it like run correctly without like making it too confusing to figure out where shirts are coming from. I could also do this, right? Before creating my first shirt, I could expect the length of all the shirts to be 0. You could add any number of expectations to a test, and that single test will have to run all of the expects and have them all return true before the test returns true. Another way to do this before I move on is we could monitor what happens as shirt.new happens, right? So, but I'll come back to that a little bit later on after we write some more tests. Let's deal with this expect syntax for the time being. So yeah, we could say expect shirt.all to equal 0 if we want, or the length to equal 0 and start from there. For now, I'm going to bring it back to what we had. Let's talk about these next tests. Expect shirt.color to equal gray, and expect shirt.brand to equal brand. Let's look at this first one, undefined method color for shirt. What's the easiest way for me to put a readable color on this? Add a reader color, great. Let's run them back. Undefined method color equals. How do I make it color equals to? Adder accessor, very good. Adder accessor, all right. Okay, cool. Expect shirt.brand to equal brand. So we could say brand here, that would work. That makes it work, right? We got from red to green. Let's refactor though, as we take a look. Color and brand. Color is supposed to be able to respond to color equals. Nowhere in this brand test did it call brand equals, and it didn't even say it's readable and writable. I think that there could even be another test saying brand should not be writable, and if I wanted to, I could write a more advanced kind of syntax saying expect that an instance of shirt should not respond to a method call of brand equals. And if it does, then we've given it too much stuff, right? What I'm trying to say here is that shirt should have brand in a reader space and not in a reader and writer space, based on how the tests are written, right? Sometimes how the tests are written for something might conflict with my human understanding of how that thing works in real life, right? If I'm on a team that wrote the tests, I might bring that up with the team. If the tests are written by a curriculum writer, they're probably contriving some sort of abstract situation that's going to force me to do some specific thing with my code, and I should probably try to figure out like the intent behind why that test is written in this case and what code I can write to rise to that. So context awareness. But in any case, now we've got still 3 passing tests, right, after I did my little refactor, moving brands to the reader space. So that kind of covers what I need to know about for a shirt. And to practice our one-to-many stuff, let's move into writing some tests for brand and then also running some tests for brand. So I think what I'd like to have is a test where maybe we'll put one more test on the shirt spec and make it a pending test. So we'll say something like this: it can retrieve its, oh no, it knows about its brand. You know what? I wrote the right number of tests here for now. Let's go into the brand spec. Totally empty file, right? So starting from here, if I wanted to write my first test for what it meant to be a brand, and remember, like if I, by the way, nothing up my sleeves, like we have a brand, right now it's got add or accessor name, and it initializes with a name, because I kind of needed that in order to initialize brands for shirts to belong to before, right? So it might have been that I start with my brand testing and then come over to shirt testing, and then I do some more brand testing later, but just for the purpose of this lesson, nah. So we'll go into the brand spec. Let's write tests after the fact now, not true TDD, but let's cover our existing behavior real quick. Kind of like feel like a CYA kind of feeling, right? Like, ooh, I'm in here, I've already got codes. This isn't true TDD, but let's fix it. So I'll say describe brand. Start with a describe block. I don't think I necessarily need a context here for class methods, but I'll create one for instance methods, just to practice having a constant scope. Within this context, what do we want to do? Well, for our instance methods, we have one that's going to be called name, right? It should have a, and did I decide it was going to be, yeah, I said accessor, and I thought about that because, like, you know, I know about Quickstar, right, because I live in West Michigan, and I'm old enough living in West Michigan, or where I'm from, to know that Quickstar used to be called, like, Amway, and that sometimes a brand needs to change its name to dodge creditors, lawyers, pitchforks. Yeah, so it should have a readable and writable name. So as we write tests like this, and you'll see instructors and curriculum writers that have written tests like this in your labs if you take a close look. By the way, take closer looks at your test code. That's Ruby code that we need to know how to read too, right? It shouldn't just be there to be a machine that turns red or green for us. We should think about how that stuff works, because most juniors are required to write tests like in their first year on the job to, like, because, you know, you're a junior. They don't know if you're going to always be kicking butt with what you do, but they want to know if this unit of work should be trusted to kick butt in the future. Therefore, automated tests are really good. In this case, it needs to have a readable, writable name. I want to write some stuff that requires me to use both the reader and the writer as this test runs, and then I can kind of like wrap it up in this one test. So I might say here something like brand equals brand.new. And then we could say here brand.name. Let's make this our first expectation. Expect that when we call brand.name, that it will equal, and that's .2, and then a space, equal element with a capital E. And then let's test that the setter works. Brand.name equals, I'm thinking a lot about Tony Hawk's Pro Skater 2 today, as I do a lot of the time. So I'm not really testing the reader the second time so much as like confirming that the reader works the way it works the first time. This is the first time I'm not really sure if this brand.name reader is going to work. But if it does work the first time, it's definitely going to work the second time. And in the middle, we're testing whether the writer works too, right? So let's see if this all goes. The nice thing about RSpec is I can say like RSpec, and I can specify one file. So I want to walk away from the shirts for a minute. I can say spec, brand spec, and it's just going to run the one test that I wrote in brand spec now. Or I could say RSpec, and it's going to include the brand spec tests along with the other 3 that I wrote in shirt. Those are the choices that I get. Well, that's kind of weird. Huh. Why did this work? Why did RSpec work, but RSpec, spec, brand spec didn't work? What's the error? Very good. If the error is uninitialized constant, that usually means that I misnamed a class definition or I didn't require it correctly. When we had our brand spec and our shirt spec, right? Shirt spec knows about the classes that we're talking about because we wrote the requirements in here. But we didn't write those requirements in to the brand spec. So I think we should. Let's do this. Require relative brand, right up at the top. Now let's try it again. There's a passing test, great. So we move on, right? We write the next test. Wrong, what did I just say? We go red, green, refactor. This is the tough thing. If you're doing TDD and you're trying to do red, green, refactor, you will have to break your code on purpose, right? Let's break our code on purpose. What if when a brand got created, it didn't actually set a name? What if it set something called a name, right? That would probably break how the reader works. It would probably break how the writer works. But here's the thing. If I can only change one letter in this file and make this test turn from green to red, I've answered a much deeper question, which is, what if I screwed up and I'm not even testing the code that I'm writing at all right now? Holy crap, right? And I've answered that question with a resounding and confidence-inspiring no. I know that I am where I am, right? And why? Because we expected element, we got nil. Why did we get nil? Well, because we set an instance variable that doesn't match the name of our attr accessor. So the value of attr accessor, like name, is always going to be nil because we don't really have a way to get that set, at least the first time, right? For later on, when we set the name to 0 and try to get 0, that would work. So my test needed to include a test for the name when it was first initialized and a test for the name after I set it, or else I could have gotten a false green here. But now I know that my test is actually testing code that I wrote. So now I put the M back, things look good, and then we're back to green, right? But that's an earned green now, because I had to go from red to this green. And now I can look and go, do I need to refactor this? And I can tell at a glance that I don't, right? I might think to myself, do I want to have that initialize taken a hash like we talked about instead of just one argument? Maybe, I don't know, probably with one argument, who cares? With more than one, the hash is giving me more benefits. I might decide at that point to refactor it to take a hash, but spoiler alert, I'm not going to refactor any classes to take a hash today. Just want to talk about the ins and outs of testing and do a little bit of review of this one-to-many. So let's move on. In the brand spec, it has a readable, writable name, and let's move on to the hard part right away. It should have, you know what? I don't like should. Let's be even more strident. Has a readable, writable name. It has a readable list of shirts made under the brand. So what do we need to do here? For this test to run in a hermetically sealed environment, I feel like we need to create a brand. We need to create maybe, let's make a brand, let's make 2 shirts that belong to the brand. And then if we call brand.shirts, there should be an array with those 2 shirts in there, right? And maybe to make this test like really fleshed out, we make like a shirt that shouldn't be in the output, right? To really test it, we make 3 shirts, but only 2 of them belong to a certain brand. So that's what I'm kind of thinking of, right? Let's make 2 brands and 3 shirts. Let's make 2 of the shirts associate with that first brand, and then let's call first brand.shirts and look for the right 2 shirts in the output. If we get 3, that means that we're not filtering right. If we get 0, that means we're like doing a big whiff. If we get like 1, that means we might have done a typo maybe or something like that. And even as I'm writing tests, I'm thinking through all of the possible outcomes and what they might mean about mistakes that I might make, because ultimately as a programmer, I'm trying to figure out where I'm going to generate a bug. And the better I can be at programming in a day is the shorter I can get between generating a bug and fixing the bug. So like thinking about these possible futures before I start going down a track keeps me from going down the wrong rabbit hole and missing the right gap in my own work. So let's do this. Brand 1, let's do, I don't know. What are other brands? Fine. Pardon? Sure. Brand.new, Nike. Abercrombie's too long. I'm just going to call it Fitch. There was a falling out. And then we'll make some shirts. We'll say 1 equals shirt.new. And we'll make this one belong to Fitch. It'll be black. And 2. I'm actually going to label these a little bit better because, like, what time is it going to cost me to read later on and try to remember what I was numbering versus just to type the name of it, right? Cost me 5 seconds now, saves me 5 minutes later. Shirt.new. Let's see, green. Fitch. Shirt 3 equals shirt.new. And this will be our red herring. All right, settle down, everyone. All right, so it's got a readable list of shirts. We've made our 2 brands. We've made our 3 shirts. I'm expecting that if I call Fitch.shirts, because of the order that those shirts are being put into the shirt.all array when they get created, I'm expecting that shirt 1 comes out first and shirt 2 comes out second. So I could say expect Fitch.shirts 2 equal. And I'm allowed to build an array and just refer to the variable names. Shirt 1, shirt 2. Cool. That's what I'm expecting it to do when it runs. I'm expecting it to fail up front because we don't even have a method yet. Oh yeah, uninitialized constant shirt. We don't even have the shirt in here yet. Let's bring that in as well. So what I can do here is like Command L, Command C, Command V a couple times, and then arrow back and change it. Command L is what gives me the whole line to copy. Let's try it again. That's better. I mean, that's the error that I wanted, which was undefined method shirts for a brand, right? We know this method should exist because the shirt already has a method brand to get to its one brand. Now we're just going to do the other side of the equation. But this is like a little review of one-to-many. The way that we've set this up, we're not trying to say that the brand should have an instance variable shirts that returns an array of shirts that stays on the brand. We've totally decided that shirt.all is the one place that we want to store shirt instances, right? And if we haven't decided it, right, maybe we'll think about it at this point and go like, do I make 2 arrays of shirt instances? But then I start thinking about, I don't know, what if like a given like brand decides to drop a given shirt? Now I have to get that shirt out of that brand's array and I have to get it out of the shirt.all array at the same time. That could be a little dicey. What if I forget a step, right? Kind of like just now, I forgot to bring in shirt. Right, I brought in brand but not shirt. What if I had to do that shape of remembering every time I'm trying to like dig deep into some like algorithm logic? Then I have to do too many context changes. That's no fun. Anyways, we've got our test failing because there's no method shirts. I feel like the job now of a brand is going to be to rummage through all of the shirts that there are and just try to match the brand on that shirt with its own self, right? So what we could do, define this method. For a brand to get to its shirts, we know that there are lots of shirts in shirt.all. Not all are mine. The ones that are have me as their brand. I need those. Where do I start? What syntax do I start playing with here? Shirt.all. Does everybody agree with that? I think that's a fine place to start because we don't really have any other place that an array of shirts is living. Let's start with shirt.all. I don't need all of them because they're not all mine. What's something I can use to iterate through and pluck out just the ones that are mine based on some like condition of matching? Select, right? Select, I feel like the pedal that drives the select bike is a Boolean, right? And I feel like the pedal that drives map is like the return value because that whole value gets put into the array. But in select, we just have a Boolean. If the Boolean is true, then the item we're iterating over gets put in the output. So select is never going to transform a shirt into just a shirt color, right? Map would be good for that. Select is like about taking a list of 4 shirts and paring it down to just the 2 shirts that we care about. Or in this case, going from 3 shirts down to the 2 that we care about. So we call .select. What's a good name for our block variable?
Shirt.
I like shirt. Makes sense. I like shirt and I do go outside, so I'm like, yeah, I did do end. Shirt. So what does a shirt have that points back to this brand? Yeah, we have shirt.brand, right? We gave it a reader of brand, so we can call shirt.brand from here. Now, if I just left it here, I'd have a problem, because like a shirt.brand is a truthy thing in Ruby. So like since every shirt has a brand and since every brand is a truthy thing, this would make every single line of the select return true, and I just end up with a copy of shirt.all, right? So this has to be false sometimes. So I need to be more stringent than just saying shirt.brand. What am I testing against shirt.brand? Self, very good. Is the shirt's brand the same as me? If so, we should have all of the shirts that we want. Let's run this test again. Boom, red to green. I like it. Okay, here's the thing, like in terms of refactoring, this is actually a pretty small line. Maybe I decide to take a look at how it looks on a single line. Right? And the smaller that the scope is, the smaller the variable is allowed to be. So like maybe I do say like just S here, S standing for shirt, right? I'm not sure if this actually makes it like less readable or not. Honestly, on the same line when we're talking about shirt.all, and I'm thinking that we're gonna have shirt instances, this feels like a nice terse way to write this line of code that I'd expect to see out in the wild. This could be okay. The main thing is that now that I've got green, I can play with it. I can move things around and make sure that as I've moved things around, I didn't inadvertently break something else, right? That's the main reason that we write these tests, is so we have code to stand on through our refactors. Is there another behavior that we need here between a brand and shirts? Oh, what about this? What if we said it also has another behavior? It can tell you the longest color name associated with one of its shirts. So now this would beg for a let because I'm about to mess around with this again. Second I'm about to copy it, that's where I'm like, let's do a let here. So I'm gonna move this up and I'm gonna re-indent this stuff. And then at the start of all these lines, I'm gonna start with a let in opening parenthesis and a colon. Then I'm gonna go here and put closing parens in all the spots. I'm holding down the command key as I click around. And then instead of equal signs, these will all need to turn into opening curlies. And then at the end of each line, we're gonna need closing curlies. So we could also just go to the beginning of each next line. We're feeling just super cheeky. Ooh, let's make it E40 sounds. Ooh, tell me when to go. All right. I had dreads at the same time that song came out. It was pivotal. I never ghost rode a whip though because I was raised in the suburbs, so there weren't a lot of straight streets. That was my main excuse. It's like too many cul-de-sacs and windies. Better for sledding than ghost riding. So we have Nike, Fitch, shirt 1, shirt 2. I'm feeling like here, Fitch.shirts should equal shirt 1, shirt 2. That still reads. I feel like this test actually becomes a little bit less descriptive when like you boil it down to this, but then the presence of more tests that use the same values can help provide context. So here, it can tell you the longest color name. It looks like the longest color name. What about this? Instead of green, there's gonna be turquoise now. I opened up for turquoise Jeep one time, back in the day. Not too long ago though, they're pretty current. Do and, so the longest color name associated with the brand of Fitch should be turquoise. Longest color to equal turquoise. Something like that. I spelled it the same way both times. I don't know if I spelled it the right way either time, but I'm consistent internally, which is what I'm trying to check for right now. So this, I think that longest color is an undefined method. And it is an undefined method. Okay, let's figure out how to implement this. Because we played with one thing through like a one-to-many connection when we first talked about it. We didn't kind of talk about how we can leverage that. Now that we have like a shirt or a brand that can find all of its shirts, I feel like it can use that as a springing off point to answer questions about all the shirts associated with the brand. So like longest color, let's play with this. Longest, most, it's like I want to find a maximum kind of thing, right? Does anybody know like if Ruby has an enumerable about finding maximums? Dot max. It's true. We have something called dot max. Let's do a little lookup game. Ruby max array. Yeah, enumerable. Remember when I said like sometimes we have it shows up on enumerable docs, sometimes it's array docs, sometimes it's hash docs. Picture class array, include enumerable. Class hash, include enumerable. Once you get through that point in like the module labs, it becomes clear that enumerable is all the shared methods about enumerating over things, which array and hash happen to share together. So that's why a lot of times we'll find it in the enumerable docs. So get in here, crack into that max. Pew, pew, pew. Returns the object with the maximum value. The first form assumes all objects implement comparable. The second uses the block. Okay, so like the max here is like the latest alphabetical when it doesn't use a block. It's just it's checking characters or it's checking numerical values. We've got more complex objects than that, right? I probably can't pass in an instance of shirt here and have it compared naturally. So we need to use this block in what's called the spaceship operator. The spaceship operator basically compares one thing with the thing that's next to it and then assigns a positive or negative integer based on the comparison of those things. And notice that in here we can say a.length, b.length, and hey, this is kind of exactly what we're trying to find out, right? Dot length of the color name of a given shirt. So let's bring this in, but I'm gonna bring it in with my brain in my hands as opposed to just a copy paste clipboard. So we have a.max, so we have this array that we're maxing out. Then we set two variables inside the pipe of what are the two things we're gonna be comparing. So we might say shirt one, shirt two, and then we're gonna call, I think, shirt one dot color dot length and spaceship it with shirt two dot color dot length or something like that. So let's try. Longest color, I'm gonna start with shirts. Why? Because I have a method called shirts, right? No local variable in here called shirts, so I'm sure that Ruby's gonna find the method for me. I'll say shirts.max. Actually, I need the max color, don't I? How do I turn the shirts just into a list of colors that live on the shirts? Pardon? I heard map, yeah. That's because if select is going to take a true or false thing and return the whole item, map is going to take a block that returns something and returns that return value. So if we can make it return just shirt.color, then we'll just end up an array with just shirt colors in it. So if I say here all colors equals shirts.map, here's a really fun shorthand, right? I'm going to say shirts.map, each shirt has a reader for color. I'm going to say ampersand, and then I'm going to pass in the symbol of the method I want to call on each shirt. It's allowed. We can do this with map. This is basically me saying shirts.map, do shirt, shirt.color, end, right? It already knows that in the array it's going to have an instance of whatever I've got, and it's going to try to call color on each of those instances, whatever they are. If I've accidentally passed it something that doesn't respond to a method call of color, that could throw me off, right? But this is going to give me my colors. It's a fun little terse map shorthand. And then within this colors, let's try our max. All colors. Actually, I want to see what this returns. So I can use a failing test, knowing that the failing test is going to print out what it got and what it expected. I can test how just this is working now in this partially finished method. So why not? I'm a huge proponent of letting my errors teach me. I wrote them. I might as well get something out of them. Oh look, expected turquoise, and then it got an empty array. I'm not expecting an empty array, y'all. Like, at all. At all. So what's happening here? I really wanted this stuff to run, right? Like, I have this, the problem is this lazy loading, right? I never referred to the words, and it's failing multiples now, right? It's expecting this array of shirts, but since I moved stuff up, ooh, did I lose my, did my screen get overshared? Apologies. Let me try this. Did the monitor turn itself off? I'm very confused. It is quieter. Do the projectors drop? I just turned off my connection to the display. I can see the room in the, oh wait, no, I can't see the room in the list anymore. I just refreshed. Oh, now it's back. It's saying to enter the key code on the screen. I got nothing, y'all. I literally don't know what happened there. Oh, that's something. Okay.
I just needed to walk right here.
Thanks, Derek. Thanks a lot. Oh, now it said incorrect screen key. Now it should give me another one. 0737. Slick. Okay, I'll take it. All right. So the issue was that I had moved some stuff, right, in my spec. I moved it up into a let. The problem is that let is lazily evaluating this stuff. So I don't know if I really should have done this refactor so quickly to move things up to a let. Here's what I'm going to do. I'm going to take away this test that I just wrote, but I'm going to put it on the clipboard. And I'm going to Command Z all the way back to what I had before. Before I did all of the rewriting up here. About to there. So here's the thing I think we are allowed to do. If I remember my syntax correctly, I can say, instead of just lazily evaluate these variables as I call on them, I believe I'm allowed to pass in a before each to a describe, and then within that, it will be sure to run this stuff before each set of tests runs, right? So if this works how I'm expecting it to, I feel like that's still going to give us a value of Fitch, and it's still going to give us a value of shirt 1, shirt 2 correctly, because it's actually done the creation of the shirts before the test runs. And then I think that when we get to, the second test down here, it can tell you the longest color name associated with one of its shirts. Oh no, that's where I need to pull this in from the clipboard. There we go. I feel like when we get to this point that it will have a value not just for Fitch, right, but it will also have a value for the shirts that are associated with Fitch with their colors. Oh, but we have this one as turquoise. Cool. Let's try this again. Command K, back to where we were. Run it back. Cool. So my before each did not work as I expected it to, so I'm going to go and look this up. RSpec before each. It's these things called hooks. Oh, I wrote the syntax wrong. It's before, and then it takes a symbol of how many like befores you want to do. So let's tweak that. Apologies, every time I hop over solstice, and I'm not used to looking at VS Code. I'm used to looking at atoms, so solstice is reading the same place in my brain that the green atom logo used to read. In any case, we'll say before each, and I think this should do it. Let's try. Well, of course, we've done it again. Dastardly. Cool. Still doesn't know about local variable or method Fitch. Sure. So here's the problem with before each, is that I don't get local variable naming anymore, right? If I start using before each. So it comes down here and starts talking about Fitch, and it just doesn't like it, y'all. It's not a big fan of it. So what I can do is I can set all these to instance variables, and it's going to make them readable across different blocks, which is what I'd like them to be. So here I'm going to say Fitch.shirts. Oops. Actually, everywhere I say Fitch for the rest of it, we'll make that an instance variable, and then this will also be an instance variable, and so will this. See if that lines up for us. Apologies. Ran spec. Run it. Oh, I got another local variable that I missed. Fitch. Of course. Well, there we are. Let's try again. Cool. Back to where we were. So I had to kind of refactor this a little bit, right? Like if I'm using let, then I can use the symbol and it applies like a local variable to it. I've got this other syntax of before each if I need to literally create things before every step, but then I have to be a little kinder with RSpec and give the variables more permission to hop over scopes, because as it moves from block to block and different local name scope to local name scope, that's where it can get itself stuck. In any case, Fitch longest color to equal turquoise. We expected turquoise, and check it out, we got just the colors. So the mapping step did work, and we need to now go and do the max thing. Yeah.
I noticed that the D dropped off your describe, and I'm wondering, is that not causing an error? Oh, never mind, sorry. That was
Sorry, I was
screen.
scrolled weird. I was scrolled like this. Escribe. That's like a new, slightly shorter RSpec syntax. It's just every word has one letter removed. Oh yeah, you got to open up that T block to write a new test. Yeah.
So, also, like, this is getting treated like a class then, this describe?
Kind of, sort of. It's more of like it's a namespace. It's like a bubble around which, or within which a certain set of collected tests work. And so we could think of like a class as where we put similar methods, right? We could think of like this describe block as a place that we put similar tests, or a context block, but it's not exactly the same thing as a class. What our spec actually does is it spins up its own pseudo class, which wraps around all of the instructions in here. And so when it's running stuff, it's calling methods that pseudo class has, which triggers it to like run all of the stuff under the hood. It's kind of fascinating, but I'm also not entirely sure how all of it gets hooked up exactly. I know it's not exactly the same as a class definition though, just because we're not really doing the kind of things that we do in a class, right? We're not like writing methods. We're mostly like putting blocks inside of other blocks to be evaluated within the scope that they're in. So this piece here, right, we've called fitch.longestColor, and that has not given us turquoise because we've only got to the all colors step. So coming all the way back to where we were, which was on this max notion, right? We wanted to be able to talk to all colors, and then let's figure out which of the words in this array happens to be the longest one. So we can go and do this. All colors dot max do, and then we could say here like color 1, color 2. And we're going to use the spaceship to compare two values. Spaceship looks like this, literally called a spaceship. And then we'll just say color 1 dot length compared to color 2 dot length. And that should give us like the maximum length. What would happen if let's see if this passes the test. That does make it go green. What happens if I flip these? Am I going to get the maximum length color? Let's see. I will not. So here's the thing. I put color 1, color 2 in this order. If the order is the same in the block as it is in the variable definition, right? If I call on the variables in the same order here that I do here, it does a low to high maximum, right? But if I flip the polarity, then I get a high to low maximum, basically. It reverses it. This is the same thing with a sort, too. If you use sort, it also uses a spaceship. But if you want to do a high to low sort, then you just flip the polarities inside of the block. In this case, I do want the actual maximum, because the test that we just wrote decided that I did. Yeah?
Alright, so we have like set variables, but like what if we didn't know the length of the array we're dealing with? How would you go about that, like testing, comparing 1 to 2, and then 1, 3, 1, 4, 1, 5?
You only ever use 2. So just the fact that there's only 2 in this array, that's just a coincidence here. This maxing and sorting works regardless of the length of the input array. So if I did something like this, we'll set this to something, array. Array.max, do num, other num. And we're going to do the max based on the remainder. So I'm going to say num modulo 4, spaceship, other num modulo 4. This should work even though there's way more than 2 numbers in here. And it says that 7 is the biggest. That tracks for me because if I divide 7 by 4, then I have 3 left over. And that's the biggest possible value that modulo 4 is going to give me. I can't get a bigger remainder when I divide by 4 than 3, right? And so if I took 4 divided by 4, that's 0 left over, that's 2 left over, that's 3 left over, 0 left over, 1 left over, 0 left over, 0 left over. So yeah, 7 is definitely the maximum, and I didn't need to put in like as many arguments as there were things in the array. The way that this works under the hood is that it's constantly doing this with every one of those, right? It's got its own kind of sorting algorithm that works under the hood. Ruby actually knows how to do a few different types of sorts, and based on where you use this spaceship, Ruby does an initial judgment by like looking at your array and figuring out what sorting strategy might be the best for this. And then according to that strategy, it does the sort. The spaceship basically just helps us to understand what condition is Ruby going to sort on for us. But under the hood, Ruby is going to handle the making sure that 4 should be at the very beginning, right? And that 7 should be at the very end of this array. And then we should chop off the thing that's at the very end, and that should be the value for us. Ellis.
Sorry, it's not.
Oh, sure. Of course. Other questions?
This could also be used with min, right? Like
Per-
same word by word, except max is replaced with minimum. or
Yeah,
min.
I think so. Let's see. See if we get it, if we get the option. Yeah. If we did min and reverse the polarity, I don't know why I want to do this. Give me the one with the least minimum word length. Is kind of what I'm asking for here. That's very confusing, right? That's like doing a bang before everything and then saying unless instead of if. I might as well use no bang and just say if, right? It's double negatives is kind of the deal. But yeah, that works too. I'll bring it back to max though, just so it's like clear what I'm doing. So yeah, this is the kind of stuff that I think is really fun, right? Because we have these like complex objects that we can like map over and get certain values out. By the way, if we needed to do it this way, we could have done this. We could have said like all shirts. Hang on, let's change this up just for a refactor to try this another way. So all shirts dot max shirt 1. We could say shirt 1 dot color dot length, and then shirt 2 dot color dot length, and then at the end of this, we can output the color of the shirt that we returned. Maybe not. Did I say all shirts? Oh yeah, all shirts. My bad. Should have said just shirts.max. Here we go. That's another way to express the same kind of thing. It's clunkier though, because I have to call dot color again, like at the very end. I'd have to like have another variable for it. I think that it's actually clearer what we did the first time, to first break down from complex shirt objects to simpler color strings, and then to just iterate through with a max to hit all the colors. In terms of the one-to-many piece, this is the pattern you're going to see all the time, right? You're going to see this. You're going to see versions of this even later in the mod when we get into databases, and we're just going to transport this understanding to a database syntax. But the main piece here is that for a brand to know about its shirts, it needs to go communicating with the shirt place, right? And in this case, it's going to be the shirt class. Hey, shirt class. Yeah, what's up? Hey, I need to know all the shirts you have. Okay, cool. I've got this array here that I've been shoveling myself into every time that we get created over here. So yeah, as the shirt class, I can tell you here's all the shirts that there are. The brand's like, that's great. I know who I am. I'm going to go check through each of your shirts and make sure that your brand is the same as me, because that's the connective tissue, right? Drawing this schema out explicitly to connect brand with the shirt's brand, that's why drawing this schema helps, right? If I'm not sure what to check against self from the perspective of a brand, I can always come here and make sure that I can see where that line gets drawn. And yeah, and then I'm using a select, right? Because I don't want all of the things. I just want the things where certain stuff returns back true for me. Cool, cool. So that's a little bit on our spec and a little bit more on one-to-many. Yeah.
Sorry.
Mhm.
When we're doing this, like in reference to like the code challenge,
Mhm.
do you think it makes sense for us to be building out our spec files or just doing pry and like testing it manually?
That's a great question. I can tell you that our code challenge is going to be much more of a pry-shaped situation than our spec. It's not going to ask you to write any tests, but the other downside is that the code challenge is not going to provide tests for you. So the code that you're going to be writing, you're going to also need to be like running and testing it in real time, right? So you won't have maybe the time to put together like a whole RSpec kind of structure, right? But if you know that, for example, this is a really good example, I think, in our brand spec, that we first had to create 2 brands and 3 shirts to fully be able to test whether like one brand could hold 2 shirts but not the third, right? In order to do that, there has to be some place, like I'm in a pry session maybe I create a file that always runs pry at the end, and then I do whatever kind of setup of the driver code that I need. I create any variables, any instances, I call .new on, I get all those loaded up. That's gonna be the thing that you're gonna wanna work on. If you've been in a mode right now of writing class code that passes tests, but you've been running 5 times as much learn test code as you've been like actually writing driver code in the classes to run, you should be getting in pry more and you should be writing more driver code. And that means that like, since you can't really run pry at the same time as running an RSpec test because of the weird things in scope that are happening with RSpec, that means that you're gonna wanna get accustomed to not just running RSpec, but calling like Ruby some file name .rb. And maybe in each of these projects, you want to make your own runner file, right? Maybe in here, I could even say like, let's make something new. Where's my new file? Is this it? No. Oh, sorry, I'm in the wrong spot. There we go. New file, run.rb. If I'm over here, I need to require my shirts and my brand. And then maybe right in here, I also require pry. And then I have binding.pry will open. And maybe I borrow shamelessly from my brand spec all this stuff that I did up here. But maybe over here, I take away the instance variables because that's like specific syntax for the sake of RSpec, and I don't really need it. Gone.
Did you mean to put that in the spec folder?
Pardon? Here?
Did you mean to put that in?
Sure didn't, thank you. Yeah, this needs to go out here. Yeah, I did. There we go. Cool. So let's say Ruby run.rb. Here we go, Fitch. There's our brand, Fitch.shirts. Fitch.shirts.map. Ampersand, color. Fitch.shirts.map. Do shirt.color, end. Same deal. Cool. So now that I have this set up, every time I run like run.rb, it pops me into a pry session with all these variables. If I realize I need to test a shirt out that's purple, I can add a purple shirt to my list of shirts that I've created, come up with another variable. Notice how I'm like setting variables so I can pass those things in as arguments to other stuff. Yeah, so I think that this kind of coding is what you're gonna be doing more like on a code challenge situation. So if you're not yet familiar with like playing around in binding.pry, like now is a really good time to start making sure that that's in your debugging tools. I would also say that if you're really confident in your P or puts debugging, if you know where Ruby is going to run stuff and you can pop a P statement in there and use that to check your work, as long as you know how to start running the code that's going to trigger that P statement, that's another way. Because coming back to the very first thing we were talking about, the crucial element here is being able to expect things before the code runs, right? Something other than the unexpected, something other than catharsis, something other than being able to move on to the next test or lab, right? If I'm gonna run this, I'm gonna expect that there would be values for Nike Fitch, shirt 1, shirt 2, and shirt 3, that I shouldn't have local variables of any other kinds of values that I don't expect. I'm expecting that Nike and Fitch will both be brands, that they'll both have readable names, both have writable names, right? Can I actually go in here and change Fitch's name? Yeah. Yeah, and that's cool AF. So like I can do that still because I defined that behavior on the brand. And I'm like, as I'm thinking, right, if I was expecting that their name would be readable and writable and it wasn't, that would either mean that I got something wrong in my tests or I got something wrong in my code or I read something wrong in the README or multiple of those things, right? But if I'm always running code after setting an expectation for what I think is gonna happen, it's a more exhausting and slow way to think throughout the day, right? I'm holding more in my brain and in my heart to say I really think this is going to happen, but that also means that when things don't happen the way I expect, I actually feel that. And those feelings are going to lead me to have a deeper learning like etched into my brain, right? Learning that comes from a surprising or a subverted expectation, you can always remember that stuff. And the reason you know that's true is if anybody asks you where they went or tells you where they went, you can always ask them, like, did anything amusing or surprising happen there? and they will have a memory for you, because things that our brain says, oh, that wasn't what I expected, we like mark those things. Like they're interesting things to us. And that means that if I go through my coding day without expecting a lot, there's not going to be a lot of things that seem comparatively that interesting. So I guess my plea to you is carry the weight of expectation into your code, right? Because your code is not you. I wouldn't want to carry this weight of expectation into my regular life, because I might feel like too self-judged and just collapse under all of that like self-scrutiny. But I can scrutinize the heck out of my code. That's just stuff that I wrote yesterday. If I want the stuff I write today to be better than the stuff I wrote yesterday, I'm hoping that yesterday I set expectations as I wrote stuff. And how formal those expectations are, as simple as making a verbal call out or pointing at the stadium like Babe Ruth, or as complex as creating a whole describe context, and a context inside of that, and then a variety of it contexts to declare given tests with given matchers. By the way, if you're curious about this syntax, you can type up rspec syntax. And then check out the second link here, syntax configuration, rspec expectations. Relishapp.com is what you're looking for, because they're the ones that actually put together this rspec stuff. So in here, they talk about they have this specify expect system. They use specify instead of it. You don't necessarily need to use it. You could use specify in newer versions of rspec. There's different versions of rspec that they talk about in here too. So if you want to go back to like an old school, they'll tell you how it used to be. And then you have all this stuff on the left, right? Built-in matchers will tell you all of the things that that version knows about matching. So it'll tell you like satisfying, responding to. Respond to is like, let's test whether or not this knows a certain method call. Does it respond when I call a certain method? I don't want to go too deep into these matchers, because what usually you have is something you want to test in particular, and then you start Googling how do I test for that, and then you find the matcher, and then it guides you here, and then you're ready to really learn the matcher, because you're at the moment when your code needs it. All I'm here to do is to let you know that rspec is not as impenetrable as it seems from the outside, right? If you can write a block with a do and an end, and you can figure out the ins and outs of that expect syntax, then you'll be in good shape, and you're also surrounded by labs that have sample rspec code. The last tip I'd give you is if you want to practice this rspec in like the lowest impact way possible, the next time you're in a lab that already has rspec tests, go into a test, find a test whose code you kind of understand, come up with a new expectation that's similar to that test expectation, but that's also gonna like return true if things are working. Try to make a copy of that test right below it, put a new test in there, tweak like one thing about it, right? If you're expecting a name to be lowercase John, right? You could write an identical test right below, expecting name.upcase to be all caps John. But even making a small change like that kind of breaks through the membrane between you and writing rspec tests. So if that's your first way in, to rewrite an existing rspec test, to change something with a distinction but not a real difference about that test, I'd say that's an appropriate place to think about getting started. Takes away a lot of the other like hemming and hawing about like, well, what is the spec folder, and have I set up my describe and my context stuff right? Start with the it. You can always build from the inside out with these rspec tests. So yeah, that's what I've got for that.
Also, just last thing about the code challenge, we're not going to have like a run file prepared or anything, right?
I believe the code challenge will endeavor to provide you with a place like that's designed to bring together everything in the app and to run a pry session for you. There's also, I want to say, did Blood Oath have a console.rb to it? Yeah, Blood Oath I think is one of the best things to look at tonight/tomorrow morning if you're curious about like how a code challenge might be formatted or presented to you, or how like questions in README or features that are asked for might show up. I think that Blood Oath is a really good kind of sneak preview of type, still not necessarily of scope. I still feel like the actual code challenge is probably going to be a little bit smaller than the stuff in Blood Oath, because that's designed to be tackled like with a pair across an afternoon as opposed to tackled solo in like an hour. So yeah, you'll see like a pared down version of something along those lines, give or take. Yeah, right.
Is the difference between to equal and to be just semantic, or is there on the website it looks like there's an actual?
Let's see. Yeah. So there's all these so there's the equality equal versus B. I'll find an article for it that talks about it in different terms. Essentially, equal is like, do we have a matchup of the value that's presented here? B goes deeper and says, do we actually have the actual asset here? So if I'm expecting something to be the string hello, that doesn't really make sense because you can have more than one string hello. I'm really just checking for equality to the characters HELLO in that order. There's a lot of other ways that a string could be hello over its entire lifetime, and a lot of reasons why I wouldn't just store one copy of the string hello, because, I don't know, same reason why I wouldn't store one copy of the string Mike, right? That would be dangerous if a different person with the first name Mike in a Ruby app wanted to edit what their name was. You wouldn't want them editing yours. So we'd have a different copy of the Mike string for them to use. So EQ deals with things that there can be different copies of as Ruby holds on to them. B holds on to things that are a little bit more primal, true, false, integers, stuff like that, that only really lives in one spot in local memory. Jason.
Is that the same as the double equals and the triple equals?
Essentially, yeah, we're treading on kind of similar territory there, but it's not exactly the same because double equals versus triple equals, like in JavaScript, talks about, do we have the same type of thing? Is the value about the same, right? So like string 1 versus integer 1, that might pass a double equals, but it would fail a triple equals, which is testing for the type as well as the value. And like the string hello is also the string hello. They're both strings with the same value, but they're still not, they are not the same thing. They are equivalent because they both contain HELLO in that order, but they might live at different places under the hood in the microchips that are running Ruby right now. And so that's why they are not the same thing. They just have equivalency. Every time I say the integer 4, Ruby goes looking to the exact same spot in memory. If I say 4 plus 4 plus 4, Ruby's like, there's a 4, there's 4 again, there's 4 again, there's 4 again. Ruby never has a reason to store another alias for 4, like anywhere else than where the one integer 4 lives. So that's what being is about. When I say true in Ruby, Ruby's like, oh yeah, I know where true is. But when I say like string Duke, Ruby's like, oh shit, I need to find the character D and the character U and the character K and the character E, and then I need to put aliases to all 4 of those characters in an object that I'll call string, and then we'll put that string object here in memory. And then if somebody else goes, I need a new string called Duke, it's like, shit, I just did that. But actually Ruby doesn't remember. It makes another one, it might put it here in memory. So I can use EQ to compare 2 strings that are created, but since they don't come from the exact same spot, I can't ever be confident that they are the same exact thing, the way that I can be for an integer and a Boolean. That's just because of how Ruby holds on to values. But I'll see if I can find a blog post that goes in more detail. Other questions? Cool. Hopefully this has demystified a little bit of like RSpec stuff. But even if it hasn't, like hopefully it's bolstered you to know that like whatever it is that you're doing when you code to check and make sure that your code is running the way that you expect it to is probably a really good place to be. Like whatever you're doing, as long as you're setting expectations when you're doing it, as long as at the end of the day you ask yourself questions like, am I being specific enough with the things I'm expecting out of my code? Am I getting surprised by my codes not meeting my expectations in the same areas of lab work? Like maybe every time I work with self, my expectations are more thwarted, right? Or every time I work with a class method, I have trouble getting my expectations lined up. That's a really good invitation for me to go back and like study something or ask more questions about it. But I literally can't get there if I'm not asking questions of that format, right? So the power of expectation is huge. And I think that we've been kind of conditioned out of expecting things sometimes, like, oh no, just trust the process, go with the flow. This isn't a place to be that laissez-faire, right? This is like, I'm not gonna say life and death stuff, but it's like, it's about our future, right? It's about the trajectory that we're trying to set as developers and as craftspeople in code. And I think that really good code craftspeople are very, very precise when it comes to talking about what would they expected to happen and what actually happened instead. And then when the code is not operating the way they expect, sometimes they can talk themselves back into their own bug fix just by verbally kind of dumping their understanding of how their expectations were thwarted. So it's an important skill to learn. It makes you a better rubber duck debugger later on in life. Cool. Thanks, y'all. Woo! Yeah, it's fucking awesome. Give that guy